Hi there, my name's Jess, and I have the pleasure of introducing you to the development of antimicrobial electrospun wound dressings. My main focus of this research project was to look into how Eremophila longifolia, an Australian indigenous plant, could be used in the development of polymer meshes for wound dressings. The overall aim was to produce a polystyrene wound dressing possessing antimicrobial properties, encapsulating the endophytic extract. The motive behind this research is to find new ways to treat and heal wounds and infections. With the average adult having nearly 2 meters square of skin, there was always going to be possibility of injury. These cuts, burns, and other abrasions produce a wound, with the body's first reaction being to start the healing process to prevent infection. In order for wounds to heal properly, there are 4 phases that they must go through. Each phase has an extremely important role to complete before the next phase begins. The first phase is homeostasis, stopping any bleeding at the site of the wound. Up to 24 hours later, the inflammatory phase begins, giving rise to swelling at the injury site. Once this phase starts to reduce, the proliferative phase occurs and the wound starts to rebuild itself. Lastly, the maturation or restoration phase seals the wound. There are, however, 2 main categories of wounds, acute and chronic. Acute wounds are those that heal within a small time frame, with no complications or infections, with the average wound taking up to 3 months to heal. Chronic wounds are those that fail to heal within 12 weeks, due to factors like delayed tissue healing, prolonged inflammation, and continued infections, and are common with illnesses such as diabetes. Commonly, traditional dressings are used in wound treatment, such as gauzes and bandages. However, there have been large developments in the field of wound dressings containing antimicrobial properties. The incorporation of antimicrobial properties in wound dressings helps to speed up healing time and reduces or even fights infection. Some examples of antimicrobial properties that have been successfully used against bacteria found in wounds include honey, silver, and various essential oils such as cinnamon, lemongrass, and peppermint. Antimicrobial wound dressings are not necessarily a new development. Large pharmaceutical companies have been researching new ways to treat wounds for decades, many leading the way in electrospinning technologies. We know antibiotics are effective against fighting infection, however few are used in wound dressings. The increasing risk of bacterial resistance has led to the demand for alternative healing compounds, and natural antibacterial agents are increasingly taking the lead in this research. Eremophila longifolia is the subject of my research and is a native plant found in arid and semi-arid regions of Australia. Eremophila longifolia has many medicinal uses. Australian Aboriginal communities have used it for centuries in smoking ceremonies, such as the cleansing of mothers and infants after childbirth. Limited research has been conducted into this specific plant. However, there is some literature supporting its use as an antimicrobial agent. Sadgrove and his colleagues conducted an experiment to simulate the smoking method used by Aboriginal Australians in an effort to isolate any bioactive compounds. Results showed a substantial antimicrobial response to gram-positive bacteria using the smoke extracts. A key component of the smoke was isolated and found to be the main contributor to the antimicrobial response. As Aboriginal communities have used this plant for centuries for its medicinal properties, my research looks into its potential as an antimicrobial agent in wound dressings. To explore the effects of the antimicrobial properties, the endophytic extract from Eremophila longifolia needs to be obtained so that a polystyrene solution can be prepared encapsulating this extract. A variety of variables need to be considered, along with the polymer concentration and the endophytic extract concentration, with at least 3 varying concentrations of the antimicrobial extract to be tested. Next, the polymer solution needs to be electrospun, taking into account different parameters such as applied voltage and solution flow rate to fabricate electrospun meshes with ideal properties. Bacterial assays will then be used to understand how Pseudomonas aeruginosa and Staphylococcus aureus, bacteria commonly found at wound sites, interacts with the electrospun meshes produced, observing any antimicrobial activity of the fibers. Another large aspect of a wound dressing is its biocompatibility with human skin cells. This will be tested through analysing the transfer of skin cells onto the fibres as well as through wound models, assessing any cytotoxicity of the dressings. Endophytic extracts from plants such as Eremophila longifolia have the potential to be a promising natural antibacterial agent in wound healing devices. With further research, there could be exciting developments that will ultimately reduce healing time and alleviate infection. This field of research has the potential to have a huge impact on the lives of those with chronic wounds and infections, and any new developments in this area is a step in the right direction.